The calendar showed June 7, 1940. Chrysler's main offices sat in Highland Park, Michigan. A telephone conversation that would take exactly 7 minutes to complete was about to set in motion a chain of events that would forever change the nature of modern combat. On the line was William Knudsen, the man President Franklin Roosevelt had just brought in as his Commissioner of Industrial Production. He posed a question to the other end of the connection that sounded almost laughable at first hearing. Could Chrysler build tanks? Kaufman Thuma Keller, running Chrysler Corporation as its chief executive, gave him an answer stripped bare of any pretense. He didn't know. He'd never actually laid eyes on one. At that precise moment, the entire United States military inventory consisted of just 66 medium tanks, sitting in various compounds and depots across the country. Meanwhile, Nazi Germany had unleashed more than 3,000 panzers across the European continent in roughly a year's time. Poland had surrendered in 26 days. France fell in 6 weeks. The Germans had accomplished this through sheer coordinated power of armored vehicles rolling across the landscape in formation. Any single day of that campaign, America's complete tank inventory could have been wiped out before the sun reached its highest point in the sky. The equations were being scrawled across European soil in the only language warfare truly spoke: blood and steel and wreckage. Neither Knudsen nor Keller realized it yet, but that 7-minute telephone exchange would ignite the single greatest industrial conversion the military world had ever witnessed. Before 9 months had passed, Chrysler would accomplish something that military weapons factories had never done before. These massive 30-ton machines, tanks, would begin flowing off production lines the way automobiles did. One completed tank every 55 minutes when the operation hit its maximum speed. The entire foundation of military manufacturing would crack open and collapse. American industrial power would prove it could transform production itself into a weapon. The real difficulty sat at the foundation of everything. When June 1940 arrived, the United States ranked 19th globally in military capacity. Portugal outranked them. The country's armed forces had more horses in their stables than tanks on their grounds. The Ordnance Department, tasked with creating weapons, still used the same production methods as the First World War. Tanks arrived in the world one at a time, handcrafted in government arsenals by experienced workers who treated each vehicle like a unique creation. The Rock Island Arsenal over in Illinois, working flat out, could manage perhaps 3 medium tanks monthly. 12 weeks had to pass between raw materials entering the building and a finished tank rolling out ready for combat. Germany's approach to panzer manufacturing followed similar hand assembly paths, but German factories had been quietly rearming for years. By 1940, German production hit 1,400 tanks per year across all their facilities combined. The British, though they'd moved faster than Americans toward mechanization, still built only 1,000 tanks yearly. Every major power on Earth saw tanks the same way, as specialized weapons demanding master-level craftsmanship, dedicated factories, and months of meticulous construction work. Keller hung up and immediately dialed his chief engineer, B. Hutchinson, then called Frank Zeder, his vice president of engineering. Within an hour, all 3 men occupied Keller's office. They were facing a demand that seemed impossible on its face. The Army wanted 1,000 medium tanks. They wanted them within 18 months. And they wanted Chrysler, a company that had never built a single tank in its history, to construct an entire factory, develop manufacturing techniques from scratch, and deliver finished vehicles starting from zero experience. Hutchinson's opening question went straight to the core of the matter. How long does it take to build one tank right now? Zeder had already studied the facts. Rock Island builds 3 M2A1 medium tanks each month. Each one takes 12 weeks. Skilled workers fit everything by hand. Parts don't match up perfectly. Everything requires customization during assembly. Hutchinson's pencil moved across his calculations. 3 tanks per month meant 300 tanks in a year. 1,000 tanks would require 277 months of production. They had 18 months. Keller's words became the North Star for everything that followed. We don't manufacture tanks the way the Army does. We manufacture them the way we know how. If the military wants 1,000 in 18 months, They need to think like the automobile business. We need to see what we're actually building. Days later, the three traveled to Rock Island. They watched the process unfold. Workers hand-fitted armor plating against the hull. They adjusted track tension by eye, and experience accumulated over careers. They machine-cut individual parts to make up for size variations that cropped up between supposedly identical pieces. The tank in production was the M2A1, weighing 19 tons and equipped with a 37mm cannon. Around 8,000 separate pieces went into construction, all manufactured with loose tolerances that demanded expert hands during assembly. No factory floor would have two identical tanks. Keller saw the real issue immediately. This isn't factory work, this is sculpture. Each tank depends on what these craftsmen can do. You cannot speed this up. You cannot train replacement workers fast enough. Getting 1,000 tanks in 18 months. That's not possible working this way. Back in Detroit, they formed what they named the Tank Committee, a confidential group assembled to solve what seemed unsolvable. Owen Shelton joined as Chrysler's production engineering lead. They brought in experts in tooling, in materials science, in supply chains and logistics. The committee occupied one conference room at Highland Park, meeting every single day, frequently through midnight hours. Their solution came from flipping the entire question on its head. Rather than asking how to produce tanks more quickly, they asked how to manufacture tanks with a completely different approach. One of them articulated the kernel of insight. An automobile weighs $2,000 worth of materials and costs $2,000 in manufacturing. 1,000 parts go into each one. We build 3,000 every day at Highland Park. A tank costs $30,000 in steel and materials. 1,000 parts go into it. The only real difference is what we're assembling. This single shift in thinking changed everything that followed. If a tank was just another mechanical assembly problem, then the principles that worked for automobiles could work for tanks. But this required complete reimagining of every aspect of tank production. Every component had to be redesigned. Every assembly step had to be engineered differently. Every quality control process had to move away from skilled judgment toward measurable numbers. The committee dissected the M2A1 design and found that 60% of the time went to custom fitting and adjustment. Parts manufactured using military arsenal standards had so much variation between pieces that assembly demanded constant modification. Hutchinson proposed something radical. We make every component to automobile manufacturing standards. Then they assemble without any adjustment needed. Military engineers thought this was fantasy. Tank components endured stresses automotive parts never faced. Achieving precision at automobile standards would demand new machine tools, new suppliers, entirely new quality control approaches. But production time would crash downward. A tank needing 500 man-hours when components were hand-fitted could drop to possibly 150 man-hours if precision components simply bolted together. Shelton took the concept further still. If we're operating like automobile production, we need an assembly line. Forget craftsmen surrounding a stationary tank. Picture a line that moves, bringing the work to workers who stay in place, each doing one specific job. By November 1940, the committee had completed what they called the Chrysler method. Every major component would be made to precision standards using automotive production equipment. Armor plates would be identical and interchangeable. The hull would be welded together using production molds rather than hand-fitted. The turret would attach using standardized connection points. The power system would incorporate as many automotive components as feasible. Final assembly would happen on a moving line with each station designed for specific operations. Keller walked the Chrysler method into the Army Ordnance Department in November 1940. The military engineers met it with suspicion that bordered on hostility. Automotive precision standards weren't tough enough for battlefield vehicles. Moving assembly lines would wreck quality control. Welded armor plates were inferior to riveted ones. Producing 10 tanks daily was pure fantasy. But Keller had one point the military couldn't counter. You need 1,000 tanks in 18 months. We're saying we can provide them. Who else can make that promise? The Ordnance Department had no answer. Late November 1940 brought an extraordinary contract. The Army would finance construction of a new tank factory. Chrysler would design it, equip it, and run it. One additional stipulation came with the agreement. The Army demanded that Albert Kahn design the facility. Kahn was the Detroit architect whose innovations had transformed how factories got built. The Ford Highland Park plant and the River Rouge complex bore his signature. These were the facilities that made automobile mass production possible at enormous scale. Albert Kahn turned 71 in 1940. His family had fled Germany when he was 11 and arrived in Detroit in 1881. He never sat in architecture school classrooms, instead learning through apprenticeship as a young man. By the time 1940 arrived, his company Albert Kahn Associates had 600 architects and engineers on staff. 19% of every architect-designed industrial factory in the country carried his firm's fingerprints. Kahn's talent was seeing factories as machines themselves. His plans maximized daylight, smoothed material flow, and designed column-free interiors that gave production space flexibility. He pioneered reinforced concrete construction, which meant larger open floors and much faster building than steel frameworks allowed. When Keller brought the tank arsenal idea to Kahn in early July 1940, he described requirements that seemed to contradict each other. The facility had to hold the complete tank assembly operation, plus all component manufacturing. Construction had to finish in months to hit the April deadline. The building needed to resist bomb strikes. After the war, it needed conversion to civilian manufacturing. Kahn accepted the assignment and mobilized his entire organization. Working 18-hour days, teams drafted the Detroit Arsenal tank plant. The primary structure would stretch across 1.25 million square feet, under a single roof, one of the biggest industrial buildings ever constructed. 3-foot concrete walls in vital areas could withstand direct bomb impacts. The roof included steel reinforcing designed to funnel bomb explosions away from windows and air systems. The internal layout reflected the Chrysler method's logic. A main assembly line would span nearly a quarter-mile through the building's length. Component production lines would deliver major assemblies to the main line in controlled timing. Machine shops in the northern sections would build powertrain components and precision parts. Welding operations in the southern regions would fabricate armor hulls and turrets. The design ensured materials moved in one direction only, from raw steel on the west end to finished tanks departing from the east. Kahn included a detail that military engineers had never contemplated. The assembly line would descend below the floor level, creating a trench roughly 4 feet down. Tanks would ride on special platforms in this trench, letting workers reach underneath without jacks or pits. This one choice would eliminate hundreds of hours per tank by making suspension and powertrain work substantially less complicated. On September 9, 1940, ground was broken across 113 acres of former farmland in Warren Township, Michigan, just north of Detroit. The location offered proximity to existing Chrysler plants and access to railway lines. Construction moved at breakneck speed. Multiple construction crews worked simultaneously. Foundations poured, walls rose, utilities went in. Kahn's reinforced concrete approach meant rapid progress. Sections hardened fast enough to support weight within days. By February 1941, the main building stood complete structurally, though far from finished in every detail. Walls were up. Windows remained uninstalled. The roof was done. Interior systems were nowhere near finished. Yet Chrysler began moving machinery into the building. Rail cars delivered machine tools. Workers installed equipment as construction continued happening around them. The remarkable part was the timing. Chrysler had promised the first tank by April 1941, yet the factory wouldn't be truly complete until May at the earliest. Keller announced a decision that would become legendary. We're going to build the first tanks in an unfinished building. The conditions created that winter were strange and difficult. February and March in Michigan bring brutal cold, temperatures regularly dropping below freezing. The Detroit Arsenal had walls under a roof, but heating wasn't installed yet, and windows were still going in. Workers assembled tanks while wearing heavy coats, breath visible in frigid air. The answer came from improvisation. A steam locomotive was brought inside. Its boiler heated the immediate workspace. A steam locomotive inside a factory, exhaust billowing to warm workers assembling tanks. It captured perfectly the sheer will pushing the program forward. This wasn't planned carefully. The machinery of war demanded absolute focus. While production timelines drove every decision, the tank committee pressed forward, solving one engineering crisis after another. The transmission stood as the first barrier to overcome. The original M2A1 transmission was built piece by hand. Chrysler's engineers fundamentally reimagined the entire system. They borrowed principles from automobile manufacturing, creating a transmission that could roll down an assembly line, tested completely, and installed as one unified package. The result was stunning. What once consumed 40 grueling hours of labor now took just 4. The suspension system faced equal demands for transformation. Chrysler's team took every single component and standardized it ruthlessly. They created jigs and fixtures that let workers assemble and test the suspension bogie before it ever touched the tank body. A complete suspension system could now be finished in 2 hours. Mounting it to the hull took merely 20 minutes. The armor hull presented obstacles that seemed almost insurmountable. Traditional tank construction meant riveting countless metal plates together. Every single rivet demanded hand drilling, then installation, a process consuming weeks of labor. Worse, rivets were dangerous. When rounds struck a riveted hull, the rivets could snap and scatter like shrapnel inside the crew compartment, turning the tank into a metal coffin. Chrysler's proposal shocked everyone. They wanted to weld the entire hull. Military leaders reacted with alarm. Welded armor had never actually seen combat. Nobody could guarantee it would perform. Welding generated intense heat that might weaken the steel. It required welders with real skill, not everyday factory workers. Chrysler examined each objection systematically. They welded test pieces and subjected them to ballistic testing that proved welds stronger than rivets. They developed heat-treating procedures that eliminated stress damage. They proved that average workers, with just 2 weeks of training and the right positioning jigs, could create acceptable welds. March 1941 arrived with component production finally ramping up. April would see the first tank roll onto the line, assembled from parts built across multiple Chrysler facilities and brought together for final assembly. The engine question demanded creative thinking. The original M2A1 ran the Continental R975, a radial aircraft engine producing 400 reliable horsepower. Continental simply couldn't build engines fast enough to feed Chrysler's ambitions. A breakthrough came from engineer Harry Wilson. Chrysler had been developing a new inline 6-cylinder engine generating 115 horsepower. Wilson proposed something unorthodox: link 5 of these engines together into a single power plant. The idea sounded crazy. 5 separate engines driving one output shaft created engineering nightmares most people considered unsolvable. Chrysler's engineers loved unsolvable problems. Wilson led the team that designed what became the A57 multi-bank engine. Picture 5 complete inline 6-cylinder engines arranged in a circle around a central gear case. Each engine turned a gear that meshed with the central output. The result was 425 gross horsepower and 370 net horsepower from 30 cylinders, displacing 1,253 cubic inches. It was bizarre, complicated, and utterly unique. It was also genuinely brilliant. This contraption solved multiple problems simultaneously. It used existing engines and tooling, meaning production could start immediately. No exotic materials needed, no specialized manufacturing techniques required. Relatively untrained workers could assemble it following clear procedures. Military brass despised it, dismissing it as a ridiculous Rube Goldberg machine. But they couldn't argue with the production schedule it enabled. April 12, 1941 arrived, one day before Easter. The Detroit Arsenal tank plant remained incomplete. Whole sections had no walls. Windows hadn't been installed. The heating remained unfinished. Yet there on the factory floor stood the first M3 medium tank, assembled by Chrysler using automobile manufacturing methods. The M3 carried a larger 75mm gun mounted in a sponson and a 37mm gun in a full rotating turret. The design was already outdated, a compromise between what worked and what urgency demanded. But it was the first tank ever produced on an automobile assembly line. Ceremony marked its completion 12 days later. April 24, 1941, the finished M3 rolled outside the still incomplete factory. Military officials, Chrysler executives, local politicians, and factory workers watched. Keller himself rode inside as the tank emerged into spring sunlight. The demonstration showcased everything the skeptics needed to see. The 28-ton M3 roared across the test ground, accelerated hard, smashed through barriers, fired its weapons, and proved that production methods hadn't sacrificed combat performance. The crew drove straight through a wooden farmhouse, leaving it obliterated. What observers didn't fully grasp was what lay behind that single tank. A production system had awakened. The assembly line operated smoothly. Component production ramped upward. Supplier relationships formed. Hundreds of workers mastered their tasks. May brought one tank completed every other day. June meant one daily. July saw 2 tanks roll off consistently. Chrysler attacked the supplier problem with equal determination. Every single tank needed roughly 8,000 different parts. Manufacturing everything in-house meant impossible expansion. B.E. Hutchinson shouldered the supplier effort, traveling across Michigan and neighboring states with a simple message. We need these parts, built to these standards, in these quantities, on this schedule. Can you do it? Suppliers hesitated at such demands, but Hutchinson offered something valuable: technical support, advance payments for equipment, and long-term guaranteed orders. The supplier network expanded throughout 1941, eventually reaching over 400 companies spread across 32 states. A Pennsylvania foundry cast final drive housings. Wisconsin machine shops manufactured track pins. An Ohio forge supplied armor plate, the pattern repeated across the nation. Chrysler had woven industrial strength across the entire country. The workforce transformation matched the supply chain explosion. June 1940 found Chrysler with zero tank manufacturing experience. By August 1941, the Detroit arsenal employed 5,800 workers learning tank assembly from nothing. Chrysler established training schools where new hires practiced on dummy fixtures before touching actual tanks. A worker assigned to transmission mounts spent 2 full days practicing before ever approaching a real tank. This approach brought people up to speed quickly without destroying productivity. September 1941 reached 4 tanks daily. In North Africa, the M3 proved itself valuable. British tankers, receiving M3s through Lend-Lease, called them Grants after Ulysses Grant. They valued the reliability, though they grumbled about the tall silhouette and the sponson gun that couldn't traverse properly. Chrysler engineers were already planning the next generation. The tank committee had known from the start that the M3 was temporary. A gun in a sponson limited movement and made tanks unnecessarily tall. Better design meant mounting the main gun in a proper rotating turret. Chrysler and Army Ordnance engineers developed what would become the M4, destined to become the most recognizable American tank of the entire war. The M4 kept the M3's hull and suspension, but placed a 75mm gun in a fully rotating turret. The shift from M3 to M4 proved assembly line flexibility. Rather than shutting down for retooling, the factory gradually introduced M4 parts while finishing M3 orders. By February 1942, the line produced only M4 Shermans. The M4 Sherman was conceived from conception for mass production. Chrysler engineers shaped every design choice to ease manufacturing. Hulls used large castings or welded sections, requiring minimal fitting. A single casting formed the turret at specialized facilities. The powertrain employed standardized interchangeable parts. Even the tracks received design attention for rapid assembly. Pearl Harbor shattered everything on December 7, 1941. America plunged fully into global warfare. The cautious expansion became a frantic sprint. Tank demands that seemed huge in 1940 became comically inadequate by 1942. Chrysler kicked production into overdrive. The 4 tanks daily from September 1941 became 12 daily by March 1942. July 1942 saw 18 tanks roll off every single day. The acceleration demanded solving countless problems. Bottlenecks appeared constantly as operations fell out of sync. When qualified welders ran short, Chrysler opened welding schools graduating 50 trained operators weekly. When machine tools couldn't be found, Chrysler secured priority delivery. Owen Shetland, promoted to general manufacturing manager, created a system called production expediting. Teams of specialists walked the production floor, spotting bottlenecks within hours and implementing solutions within days. The facility developed an almost religious obsession with numbers. Daily totals were posted everywhere. Every worker knew exactly how many tanks had rolled off that day, that week, that month. Shifts competed fiercely to beat each other's totals. December 1942 achieved what skeptics claimed impossible. That single month saw 896 Sherman tanks complete and delivered. 29 tanks daily. This rate exceeded all other American tank plants combined. The Detroit arsenal outproduced the entire German tank industry alone. Relentless refinement generated this achievement. The assembly line operated with mechanical perfection. Tanks progressed from station to station every 55 minutes. Workers had honed operations through months of repetition. Suppliers delivered with such consistency that inventory minimized. Quality control became scientific precision, with inspectors verifying every measurement at each stage. The 896 tank month represented peak wartime efficiency. Subsequent months maintained impressive numbers, but December 1942 held the single-month record for the entire war. Tank production had transformed from craft to industry. Success bred demands for duplication. The Army wanted tank capacity distributed nationwide. Additional plants opened operated by General Motors, Pressed Steel Car Company, and Pacific Car and Foundry. Each adopted assembly line methods and precision manufacturing, but the Detroit arsenal remained incomparable in volume and efficiency. By war's end in August 1945, the facility had produced 22,234 tanks across various models. This represented roughly 25% of all American tanks built during World War II. Tanks evolved continuously throughout production. The Sherman sprouted multiple variants, each adding improvements. The M4A1 featured a cast hull. The M4A2 employed twin diesel engines for better fuel efficiency, serving British and Soviet forces. The M4A3 mounted the Ford Gav 8 engine. The M4A4 used Chrysler's A57 multi-bank engine. Each variant demanded production adjustments, yet the core assembly process remained fundamentally unchanged. This adaptability represented another production triumph. Craft manufacturing required rebuilding everything for each design change. Assembly line production simply needed fixture modifications and updated instructions. The Sherman's legacy remains debated. German Tigers and Panthers carried thicker armor and more powerful guns. Sherman crews faced nightmare odds in direct tank-to-tank fighting against these heavyweights. But Shermans possessed advantages that mattered more overall. Reliability meant sustained operational readiness that German tanks couldn't match. Standardized components and trained mechanics meant repairs happened quickly. Overwhelming numbers ultimately determined victory. Mathematics told the strategic story. Germany built approximately 24,000 main battle tanks from 1939 through 1945. During the Second World War, industrial production became the unspoken battlefield where nations truly tested their mettle. The Soviet Union commanded vast resources, assembling roughly 105,000 tanks across the war years. Britain, working within tighter constraints, managed to produce around 28,000. Then came America, entering serious tank manufacturing in 1942 and rolling out between 88,000 and 90,000 machines by 1945. The sheer numbers masked something far more significant. One facility in Detroit bore responsibility for approximately 1/4 of all American tank output. But raw production figures reveal only half the story. The genuine revolution happened in the method itself, in how tanks moved from concept to battlefield. Before 1940, every major industrial power viewed tank manufacturing as specialized military work. It demanded years of trained expertise and government-run arsenals staffed by highly skilled craftspeople. Then Detroit Arsenal changed everything. Suddenly, tank production became industrial work, demanding engineering skill and production knowledge, yes, but not the sacred mystery military tradition had made it seem. This shift in perspective opened entirely new possibilities. Production could expand rapidly by pulling in private manufacturers. Workers could be trained in weeks, not years. Supply networks could stretch across continents, with different suppliers handling different components. Production continued even when experienced workers marched off to military service. The factory itself became more resilient, more flexible, more American. When peace came, Chrysler kept running the Detroit arsenal under government contract. Tank production paused briefly, then fired back up when Korea demanded American firepower. From 1952 to 1954, the facility delivered 3,443 M47 tanks. The 1960s brought M60 production. By 1979, the arsenal was manufacturing components for the revolutionary M1 Abrams. Financial pressures mounted through the late 70s. In 1982, Chrysler made the strategic decision to sell its defense operations to General Dynamics for $336.1 million. General Dynamics kept the tanks rolling until 1996, when consolidation moved operations to the Lima Army Tank Plant in Ohio. Today, that same Warren, Michigan site operates as home to the United States Army Tank Automotive Lifecycle Management Command and the Combat Capabilities Development Command Ground Vehicle Systems Center. A Michigan historical marker stands on the site, documenting how it produced more than 22,000 tanks and proved American manufacturing could become a weapon itself. The individuals who shaped this story followed divergent paths afterward. Keller continued steering Chrysler through the remaining war years, then stepped back in 1956. Albert Kahn, the visionary architect whose design innovations transformed industrial construction across the 20th century, passed away on December 8, 1942, mere months after the arsenal hit its production peak. William Knudsen, who served as lieutenant general throughout the war after receiving his commission on January 28, 1942, the highest rank ever granted to someone without prior military service, died in 1948. Those M4 Sherman tanks built in Warren fought everywhere. They stormed Normandy's beaches on D-Day. They pushed through France and into Germany. They island-hopped across the Pacific with Marine units. They served in British, Canadian, Free French, Soviet, and Chinese forces through Lend-Lease arrangements. Remarkably, many Shermans survived the war and stayed in service for decades afterward. Israel fielded modified Shermans during the 1967 Six-Day War and the 1973 Yom Kippur War. South American nations kept them operational into the 1980s. A handful still run today, preserved as physical reminders of an era when industrial might determined military outcomes. How did this transformation happen? A few engineers and industrialists refused to accept what military wisdom insisted was true. They saw no fundamental barrier between assembling automobiles and assembling tanks. Both were mechanical devices made from thousands of individual parts. Both could move down assembly lines with specialized workers handling specific operations. This notion, obvious in hindsight, felt revolutionary in 1940. It meant seeing past surface differences to perceive deeper similarities. It demanded engineering courage to modify military equipment despite military objections. It required industrial confidence to deploy production techniques that had never been attempted at such magnitude. The Detroit arsenal validated Henry Ford's earlier revolution in mass production while extending those principles into entirely new territory. Ford had demonstrated that interchangeable parts and moving assembly lines could manufacture automobiles at staggering volume and minimal cost. Chrysler proved identical methods could produce instruments of war with equal effectiveness. This realization transformed the entire conflict's trajectory. Without mass-produced tanks, American ground forces would have faced severe numerical disadvantage in armored vehicles. Britain would have struggled desperately to replace combat losses. The Soviet Union benefited immensely from thousands of American-made Shermans delivered under wartime agreements. The capacity to produce 88,000 to 90,000 tanks in 4 years belonged solely to American industrial capability. Roughly a quarter originated from a single location in Michigan. Yet perhaps the invisible achievement mattered more than the visible one. The Detroit Arsenal didn't merely manufacture tanks. It proved a concept that would reshape how nations wage war. It demonstrated that private industry could solve government problems faster and more effectively than government itself. It showed that engineering expertise counted for more than military tradition. It confirmed that American industrial capacity, once mobilized strategically, represented an unbeatable advantage. This validation would influence post-war American thinking for decades. Maintaining production capacity that could convert swiftly to military purposes became central to Cold War planning. The conviction that American industry could outproduce any potential competitor became official doctrine. The partnership between private contractors and military procurement that began with this Arsenal contract became permanent infrastructure. The engineers who created the Detroit Arsenal were practicing systems thinking before anyone used that terminology. They didn't simply solve isolated problems. They constructed an entire system where components, suppliers, workers, assembly procedures, and quality control functioned as unified wholes. Every element received optimization not alone, but as part of the complete production ecosystem. This system's philosophy appeared in countless specific choices. Assembly lines sunk into trenches eliminated undercarriage bottlenecks. The supplier network, distributed geographically across multiple companies, created resilience. The training pipeline generated skilled laborers who could replace departures and support expansion. Everything was designed to expand. When production demands doubled, the system absorbed increases through additional shifts, expanded supplier orders, and enhanced worker training. When tank variants changed, the system adapted by modifying fixtures and updating procedures. Progress measured itself through efficiency gains over time. That first M3 tank, built in April 1941, consumed approximately 500 man-hours of labor. By December 1942, M4 Shermans were being completed in roughly 150 man-hours. This productivity leap, exceeding 300%, stemmed from relentless optimization. Monthly, engineers examined production data, hunting for operations consuming excessive time or generating defects. They investigated why workers struggled with specific tasks, then redesigned fixtures or procedures accordingly. They questioned every assumption, perpetually asking whether faster, simpler, better approaches existed. This continuous improvement culture, borrowed directly from civilian automotive manufacturing, felt foreign to military arsenals accustomed to unchanging procedures. Yet it proved absolutely essential for reaching the production volumes warfare required. The financial investment was substantial, yet modest, relative to output. Initial construction consumed approximately $20 million. Equipment and tooling added another $30 million. Total wartime investment exceeded $100 million. The 234 tanks produced represented value surpassing $2 billion. Return on investment measured as extraordinary by any standard. More importantly, though, came the strategic value. Production capacity from Detroit Arsenal and comparable facilities permitted American ground forces to achieve numerical superiority in armored vehicles, a crucial advantage spanning from North Africa through Germany. The Arsenal's deeper meaning lay in seeing possibilities others overlooked. When Keller admitted he'd never encountered a tank before, he acknowledged ignorance without surrendering confidence. Chrysler's engineers lacked tank-building experience, yet they possessed knowledge of constructing intricate mechanical assemblies from thousands of components. This engineering certainty, that technical expertise could overcome any production challenge, was quintessentially American. European manufacturers had accepted that tanks inherently differed from civilian products, requiring specialized shops and master craftsman skills. American industrialists perceived only machines, each reducible into components, processes, and assembly sequences. In 9 months, Chrysler progressed from zero tank production to delivering finished vehicles. 18 months later, they manufactured tanks exceeding all requirements. Within 3 years, they'd produced more tanks than most nations built during the entire conflict. The engineers and workers achieving this were ordinary people accomplishing extraordinary things. They weren't traditional heroes storming beaches or liberating camps, yet they built the implements making those heroic moments possible. This democratization of weapons production represented revolution itself. Historical warfare depended on specialized arsenals staffed by master craftspeople. Production faced limits imposed by skilled labor availability. During World War II, American weapons emerged from automobile factories and countless civilian industries converted to military output. The workers included housewives, recent high school graduates, farmers, and shop clerks who mastered specific operations and performed them repetitively. The Detroit Arsenal symbolized and demonstrated this fundamental transformation. It proved private manufacturers could build military equipment, surpassing government arsenal efficiency. It showed production techniques developed for consumer goods applied equally to weapons. It vindicated the arsenal of democracy concept. It established that contemporary warfare made industrial capacity as decisive as military strategy. Drivers passing the site today usually remain unaware of its historical significance. Nevertheless, the legacy persists invisibly. Modern M1 Abrams tanks employ production methods descended from Detroit Arsenal techniques. Contemporary military manufacturing relies on private contractors deploying industrial production approaches. The supplier integration, precision fabrication, and assembly line production pioneered by Chrysler remain standard industrial practice. That transformation from craft to industry, occurring across 113 acres in Michigan, fundamentally altered how nations equip militaries. It demonstrated engineering could overcome seemingly impossible challenges by rejecting conventional boundaries. It revealed production principles applying even to advanced military equipment. It proved American industrial capability, when properly mobilized, could manufacture victory-enabling tools in quantities overwhelming any opponent. This represented the invisible weapon that helped win the war, not superior technology or tactical brilliance or greater resources, though all mattered. The decisive advantage was treating warfare as industrial problem susceptible to industrial solutions. Keller, answering that June 7, 1940 telephone call, couldn't envision where his frank admission would lead. Yet in saying he didn't know but would discover how, he expressed the confidence that enabled victory. The designers of the production system, the operators running it, and the suppliers provisioning it engaged collectively in an achievement redefining warfare itself. They proved tanks could flow from assembly lines resembling cars. They revealed complexity posed no barrier to mass production. They demonstrated American industrial genius could accomplish what military tradition declared impossible. The story warrants remembrance not merely for what was manufactured, but how manufacturing transformed. The arsenal represented evidence that engineering thinking could solve any problem when correct people posed correct questions and rejected the notion that impossible meant anything beyond untried. Tanks have largely disappeared, scrapped or preserved in museums. The factory has seen substantial demolition, the workers have passed. But the method endures. The understanding that intricate mechanical assemblies can achieve mass production, regardless of purpose, persists throughout modern factories. The conviction that engineering solves production challenges survives in every industrial designer confronting complicated products, asking not whether we can build it, but how we build it efficiently, reliably, and at scale. That question, posed and answered between 1940 and 1945 in Michigan, altered global history. It enabled mass warfare production. It confirmed American manufacturing methods outperformed European craft traditions. It demonstrated private industry could exceed government arsenal capacity. It showed that presented with impossible challenges, engineers sometimes solve them by declining to recognize impossibility exists. This explains why the story endures, not because tanks fascinate, though they do, nor because World War II matters, though it did, but because the Detroit Arsenal exemplifies a problem-solving approach retaining tremendous power today. Recognize underlying similarities rather than surface differences. Apply established methods to fresh domains. Design systems, not isolated components. Never dismiss possibilities simply because they haven't occurred previously. In 9 months, Chrysler transformed from never witnessing a tank to producing them via assembly lines. 18 months brought exceeded expectations. 4 years delivered more tanks than most warring nations produced throughout their entire involvement. This happened because engineers viewed military challenges as industrial opportunities. They resisted tradition, convention, and pessimism. They solved the problem. That constitutes the most significant legacy. Not the tanks manufactured, but the proof delivered that engineering confidence, industrial capability, and systematic methods can achieve what appears impossible. When someone says it cannot be done, the appropriate response usually involves questioning their reasoning and collaboratively discovering solutions. That response, applied consistently and decisively, created an arsenal that sustained democracy itself.